Hello everyone, we are Team FMAD. FMAD stands for Field Monitoring Autonomous Drone. As we all know that India is an agricultural country, the agricultural production is one of the key factors in the stability of the global economy. So, correct and timely use of pesticides and proper observation of the crops helps us to boost the agricultural sector. In order to do this, we have developed a system, FMAD. FMAD is a system that is capable of spraying pesticides automatically over the agricultural land and also collect images and record videos of the field for further monitoring using various spectral imaging techniques. FMAD as a system is very low cost and has very less maintenance as compared to other systems available. FMAD increases the efficiency and also minimizes the manual work of the farmer to spray pesticides and monitor the field, which indeed becomes very beneficial. India is a fast growing country, and to fulfill the food requirements of the growing population, it is very much important to make the agricultural sector strong by using smart technologies and without causing any damage to the environment. The agricultural sector plays a really important role in the economy of the country. We need to ensure that the pesticides which are sprayed over the crops are used correctly and it is sprayed timely so that it does not damage the crop. Moreover, the time taken to spray the pesticides over the crop manually is very high. It takes around 1 to 2 complete days for 3 to 4 laborers to spray 1 acre of land. And the cost of the labor is also very high. It is around 1500 rupees per day. The proposed system is completely autonomous embedded system that will be able to fly over the field as per the coordinates set on the remote controller, as it is GPS enabled. As the proposed system is spraying over the field, the user will get a live video feed regarding the crops and the fields, so that if the user sees any kind of uncertainty over the field, he can resolve it and click images of the particular section for further examination. The system comprises of sensors, analog to digital converters, microcontroller, camera and various actuators. When any of the sensor fails or there is an error in the system, it automatically detects the error and sends feedback to the user so that the user can bring back the drone. If the user uses autopilot mode, then the drone will automatically return to the starting point if there is an error in the working of the drone. Since a microcontroller is used as the heart of the system, it makes the setup very low cost and effective. As the proposed system can be controlled via mobile handset, it becomes very user friendly. The signal is received from the MPU and then it is passed to the microcontroller. The microcontroller unit processes the signal from the MPU according to the user selected firmware and passes the control signal to the ESC. The signal instructs to make a fine adjustment to the motor, which in turn balances the multi-rotor craft. The installed control board uses a signal from the radio system and passes the signal to the microcontroller, throttle and the radar unit. Once everything has been processed, the microcontroller will send analog signals to the ESC, which in turn will adjust the speed of each motor to induce controlled flight. This was about the working of the FMAD. The FMAD can carry 10 to 12 kg of payload. That is, it can carry 10 to 12 liters of pesticides along with its components. The images which you can see on your screen are the real images of the prototype or the model that we have created. The implementation of the software part. When the FMAD is spraying pesticides over the field, it simultaneously records videos and clicks pictures of the field to check if there is any uncertainty over the field or to make further analysis. The pictures on the right side are the images which are taken from the drone, are the live images which are taken from the drone. First, the image is taken into the software, it is pre-processed and then the image is segmented into. After that, feature extraction in the image is done, which indeed leads to detection and classification of the plant disease. As you can see in the right side, there are two boxes as per the green color of the crops. If the crop is very dark green, then it says that the nitrogen is balanced, and if the color of the crops are towards yellowish, then it means that the nitrogen level in the crops is less and it needs to be taken care of. The second image which you can see on the right side is a live image taken from our drone there are 3 boxes again, which gives us the different colors which are feeded in the code. One color is raw green, the second you can see a lime green, and the third is the dry yellow. So when it is raw green, it shows that nitrogen is very much adequate. When it is lime green, it shows that nitrogen is balanced, and when it is dry yellow, it is showing that the nitrogen is inadequate. So the disease of the crops can be easily detected by the nitrogen content in them, which we are detecting using this software. Results. The proposed system has the potential to improve agricultural production at a very low cost and with ease. FMAD will allow farmers to choose aerial spraying of pesticides, which in turn will save them around 600 to 700 rupees per day, including pesticide cost. The drone will uniformly spray pesticides and fertilizers over the field, so there is no possibility of damaging the crops. The drone will save time for spraying pesticides, and also it will reduce the disease caused by fertilizer to the human body, such as skin disease, as per the research of the World Health Organization. In the earlier part of the video, you saw a quadcopter which was able to carry 4 to 5 kgs of load, but now we have developed a hexacopter which is capable of carrying 10 to 12 kgs of payload, and this is the hexacopter that we have developed. We were unable to fly this in a closed environment as there were many restrictions due to lockdown. So once this lockdown ends, we will be flying this in larger fields and handing it over to a farmer. This is the hexacopter. As you can see, the sprayer is attached down below with a tank of 3 liters as of now, but it can be increased to as many liters as they want. This is the battery here, and this is the microcontroller with the GPS. Thank you.